Hello friends, welcome to our channel. Let's have a look at problem 3831, media of a binary search tree level. In this video, we're going to present two solutions. So one solution is going to use a recursion, but in this solution, we're not going to take into consideration of the binary search tree structure. And in the second solution, we're going to use iterative method. And then we are going to take into consideration of binary search tree so that you can compare the two solutions. So here the problem statement is rather straightforward. So we are given a binary search tree and an integer level. So we want to find the media of that level. So here the media is defined slightly differently than the typical media. So it's going to, if the length of the list corresponding to that level is odd, you're going to return the middle one. And then if the number value at that level is even, we're going to return the so-called upper media. For example, if you have, say, 1, 2, 3, 4, right? So list is even, you need to return this one, 3. So in other words, you need to return, given the array, let's say, you need for the upper media, you should return array and the length of array by 2. So you don't need to do average of this 2, right? So this is specific to this problem. So if you look at the example, so level 2, here is level 2, just one element, so you return 7. Here level 1, you have 3 and 8, so 2, you need to return the larger one, that is 8. So for level 2 here, there's no level 2, we need to return -1. So here the number of nodes is given by this one. So we should pay attention to the upper bound, so which determines the problem size. So here this 2, this one is not very essential. This one basically tells the value, the level is like this. So it's possible that the level is larger than the available level in the given tree. For example, example 3, right? So with that said, we are ready to do the coding. So for the coding, first, I'm going to do a version that I'm not going to take into consideration of the binary search tree structure. So here we get level information. So I'm going to use collections default dict. So I'm going to use a container as a list. So this guy is going to get the key will be the level and the value will be corresponding list in that level, right? So here this can be easily done for any tree just using a traversal. Let's see, I'll do a traverse. So here I accept two things. One is the root, one is the current level, right? So let's start from -1 because the root will have level 0, right? So first, if not root, so I'm going to return, right? And do nothing. And then after this, we check, oh, this root is not null. So the current level should be incremented by 1. And then we level info. First, we get the append this information, root value, to this current level, right? And then we do traversals for the left subtree and the right subtree. So basically traverse root left and current level. So we shouldn't write current level +1 because here we have already did this one, right? We first check, then update by 1. So similar thing, so just copy this one and then do right. So once you do this, so you can traverse the tree. Traverse, so given the root, so you will get this information. Let's print out this level information, right? So if you look at it here, so for the first example, level 0 have a 4, level 1 have a 5, and level 2 have a 7. Well, for second, the example 2, level 0 you have a 6, and level 1 you have a 3 and 8. So notice that because the way we write the solution, so we didn't take into consideration of the order. But so here you can write a sorted list, but that is not necessary for this problem because it's a very simple problem. So first, what we want to do is we get the info, and then we get level information of the given level, right? So it's possible this one is empty. For example, in the case of example 3, right? So we just need to return. So info, if it has a length, so info, so I'm going to do this, if info. Otherwise, so we're going to return -1. So this will be a solution. So you can do a check, and then you can submit. So here, actually, I guess there's a bug for this problem, because this one, we still passed this solution, right? But here, actually, I think it's important to do a sort. This is important. So if you run, and then you do check, right? So this is the one. So this also tells that sometimes if you submit some solutions and you can pass, it does not mean your logic is completely right. So this is the one version of solutions. The second version, I'm going to write another one. So here, I'm going to put it here. I'm going to change this one to be a version we want. So for the second one, I'm going to take into consideration of take into account the BST structure, abstract data type, right? So for this, what I'm going to do, I'm going to first initialize a queue. So here as a root. So the binary search property says that for any nodes, so the left child has a value strictly less than the node value, and if it has a right subtree, the right child have the root have a larger value than the root value. This holds recursively, right? So here basically a while loop, while queue and level. If level is not 0, right? So what do we do? So we can get a new queue. So the way we get a new queue is for node in queue. So now, because we want this one to be in naturally sorted order, so we can first look at the left subtree, because the left subtree has value less than the current value, right? So if node left, so what we're going to do is new queue. So I'm going to append node left, and then if node right, so new queue, I'm going to append node right. So this way, so we can have after this, so we set the queue to be the new queue, and then the level is decremented by 1. So meaning that we are approaching the expected level, right? So what we want to do is this. So we are going to return, let's see, q length q over 2 if q. In this case, it means that we exit this while loop due to this arrives at 0, right? Else I'm going to return -1. So this is another solution. So we can do a check. So it's not valid. Let me see. If well, so new queue will be this, and then let me check again. Value 7 is not valid value for expect return type. So let me check this. Node left. I guess we should here. We should return the value. Let's see. Yeah, it passes the cases. So now let me maybe print out this information. Print out Q. So in the first one, so level 1, so you're going to have and 7. So the left is the 9, the right is 9. So for this one, so for this level, you are going to get 3 and 8, right? So for this last one, so and just out is empty, right? So here also let me look at another one. So here level if level is 0. So if level is 0, so for example, it will not enter this while loop. So you are going to have this one automatically. So you are going to return root value. Therefore, this is a correct logic. In other words, in this level, you don't need to add this root or the current node. So let me submit. Let's see output. Yeah, it passes all the cases in a very fast fashion. So with that said, I guess that's about it for the current problem. So to summarize, so we provided 2 solutions. So one is not taking into consideration of the binary search property, so then we use recursion. And then in the second one, we take into consideration of the binary search tree property, and then we use iterative format. And naturally, this queue will be sorted in their value. So with that said, thank you for watching.